Hi there, welcome back to Triplicate, and today we will be moving on with our boat speedometer, which is principally at the minute, yes, a picture. Well, we're going to be using GPS to measure speed, so I guess we need a GPS module and we need to be able to read position from it, or speed, or whatever, we shall see. So there's our GPS module, so let's us have a closer look at it. Okay, so let's have a look at it. So that is the antenna. So I'm not quite sure how this is working. That looks like a block of plastic, but it also looks like it's got a connector on there. Let's look into that. Anyway, there we have some kind of an antenna with maybe an amplifier hiding under that can, and a little connector which goes to there. Alright, there, like that, I guess. Right, well, I will have a closer look at that before I start ramming it on. And here we have some connectors which are PPS, I need to find out what that is, RXTX, ground and VCC. Now I believe it's 5 volts and I believe it's serial, logic serial, and it is basically a NEO 6M blocks NEO 6M module, so we can have a look at the data sheet for that and see where we are. And it's got a battery on it, don't know why. Presumably it's got a, oh, is that a real-time clock chip? Maybe it is, to keep onto the clock to make it establish communications faster. We shall see. No, sorry, establish position faster, should I say. Right, we shall see. Now I know we're going to be using a nuclear, an STM32, but I have here an FTDI module still in its bag. Let's see, we're wincing here, then I'm tipping this out on paper and not on anti-static, but there you go. So what I'm proposing to do is connect that straight to that, and I don't suppose it's going to go that easy. For now, power it from the USB and just cobble together some sort of little program on the PC to read what's coming out of the GPS module here. Easier than having to write code in the middle on the STM32 for now. So I will, well no, next we'll have a look at the data sheet for this, shall we? So okay, here's the data sheet for that u-blox Neo 6 module, and it tells it does all sorts of wonderful things, and it's got all sorts of interesting information which for now we are not going to get into. For now we just want to get it working. So I did look back at the listing, the original eBay listing, and it quotes here a tutorial for the Arduino. Now I know we're not using an Arduino, but it should just serve as a basic connect up which we can use. So if we go here, there it is. So they've just connected 5 volts and ground to the module, and they've connected the serial to pin 3 and pin 4. And interestingly, I didn't know you could do on the Arduino, there is available a software serial, because it only has one serial port, and that's the one it uses to talk to the programming interface. But yes, there's a software serial, and basically they are just basically reading the data and writing it out to the window, the monitor window on the Arduino. So we're going to do something like that. But first we have to wire it up, which I shall get on with now. Okay, so here's our FTDI. Here's the one that had a little jumper lead. Nice white paint mark, so I know which way around they go. And that goes in there. So far so good. Should we just power up our FTDI here? And I've done this already, so I know what's coming. And the light comes on. Thinks it's seen something. Oh no, unknown device. So it's not working. It's still found the unknown device. And if I unplug it here, the unknown device has vanished. Have I done something to it? I was trying to buzz through the connections. Maybe I've connected something to I shouldn't, or maybe I should use anti-static precautions. However, hunting in a drawer, I have found another one. And I have plugged this into the exact same FTDI interface on the battery charger, and it's fine. However, I have found another one unopened in a bag. So, shall we see if that one works? Oh. Right, the Duff one I think is the one with the paint on. And that is exactly the same site, and that's a little bit of a broken lead. So, what should we do? Put this in here and see what happens. Oh, that looks better than the LEDs flash. Blown chip, I think. See what that says. Yep. COM 6. Okay. Duff. Blown. What fun. You just can't get the stuff, that's the trouble. Right, so I've checked everything through. So that should be okay at that. So the moment of truth, power her up. Don't know, am I expecting any sort of LED on this thing or anything? Oh dear. Let's have blown that up as well. Right, so can you see what we're doing here? Yep. Do we have 5 volts there? We do. We would expect something to be happening on the little TX and RX lights as well. Is that little thing an LED? In which case, presumably, it should be on. Does it want me to connect up the antenna before it'll do anything? I don't know. I think it must just press on. There we go, connected up the antenna. We'll plug it in again and see if anything's happening. Right, head scratch time. Okay, I thought I'd blown up the GPS board as well, but fortunately no. Just the earth connection, which is the second one up on that row, for some reason getting soldered between the pin and the tiny little, it has to be said, tiny little ring you have to solder to, proved to be a little tricky. But now we have a red light, so it's powered at least, and kind of expect to be getting some data. Look, the little light isn't flashing. Yes, don't know. However, at least we've got a chance of something, and that LED is connected to the timing pulse, which is supposed to pulse once a second, so it's not actually doing what it's supposed to be doing. Maybe it just comes on permanently when the antenna can't get a fix, and since we're inside it might struggle. Right. Okay, so here is the example code for the Arduino, which is really simple. They just read. They don't send any setup or anything to it, they just read data from it. So I have written here basically a bit of code that does pretty much the same and just prints out just hex of what it receives, and see if we get anything. So if we run this up, we should get some stuff, and hit run and it opens it. Oh, there we go. Will you look at that? So, oh yeah, the LED's blinking. Okay, so we might actually try and intelligently turn all this guff. This is text, and that's my multimeter turning off. So this is text we're looking at here, so we might get it to print these strings out, and then we'll reconvene. Okay, just change the code so it prints out all the bytes it gets as characters, and sends the string to the display when it gets a return character. So shall we see what that does? Plug our jig in. Okay, there we are. You see the light is constant because it hasn't got a fix. So let's fire this up, hopefully. Right, after a bit of a wait to fix the code bug, that's typo. You see it's flashing now, so it's got a fix. So if we hit run, it's found COM6 and it is printing out a bunch of stuff. Now that is NMEA, I believe they call it, the basic standard for GPS. So shall we see if we can see what all that lot means and try and replace that with some meaningful data, some meaningful output. Okay, let's do it. So here we have the NMEA reference manual, which I guess is the official document for the NMEA, and it lists NMEA output messages, which is us, and the GGA message gives time, position and fix type data. So I think that's the one we want to look at firstly. So if we scroll down here, yep, so we have message ideas, we have UTC time, latitude, north-south indicator, longitude, east-west indicator, position fix indicator, which is north if there's no fix and 1 if there is, basically. And the number of satellites used might be of interest, and the rest is just stuff. So let us extract those from our message and see what happens. And here we have a typical message they're using in the example here. So here's the code, which I won't go through because it's fairly straightforward. So let's fire this up and see what we get. There's our little window. Run. Here we go. Fix on satellite 6. Time is, yeah, since we're in GMT time zone, it is actually 2 minutes past 5 in the evening. And there's a latitude and a longitude. Now, to be honest, really, the not too huge number of people who are likely to watch this video, I'm sure none of them exactly care where Triplicate Towers is, because obviously the GPS receiver is sitting on the bench in the office. However, call me Mr. Paranoid, that's why some of the figures were blurred when I was just putting out the raw data, and in the latitude and longitude here has been modified. So it's not showing where my house is, and if you would feed those values into the mapping app of your choice, it would be fairly obvious it's not my house. Okay, so that is working. So let us look at what else we've got in here. So we have geographic position, latitude and longitude. Not quite sure what the difference is between that and the latitude and longitude we've got from the previous message, but we'll look into that when we start looking into measuring speed and recording position. You won't worry about that for now. Active satellites, yeah, if you want to draw a little display of how many satellites you've got, that might be good. Satellites in view, similar. MSS, MSK, receiver signal. Don't know, don't want to. Right, recommended minimum specific GNSS data. This one again comes with latitude and longitude and time, so this is probably, we could probably get everything we want from this message as well. However, it does contain speed over ground and date. That might be useful if we're trying to log where we've been over several days, but it does give speed and course over ground, so that's interesting. Speed in knots. So shall we see what that does as well, bearing in mind this GPS receiver is sitting on the desk in a house, so it is not moving at all. So if we hit run, off it goes up, and you can see it's giving me a speed of 1 and some knots. Now I suspect that's just the jittering about of the position. It's just measuring the distance between two positions and calculating a speed from it, but that is not a lot of good, since we want to be able to measure down to somewhere around 1 knots, 1 mile an hour accurately. So that's something interesting to flag up and have a think about when we come to actually getting proper speed data out of our GPS data. Okay, so I'm curious to know what it does when it has no satellites, when it can't see any satellites. So to that effect, I have the Marks and Spencer's shortbread tin. and I am going to place that over the top. I think that should stop stop it seeing any satellites. Oh yep, there we go. Killed it. Oh no, still seeing some. Alright, let's go for the full Monty. A piece of paper on the lid, and we'll put the tin over the top. That seems to have killed it good and proper. Okay, let me take the lid off again, the base off, anyway, whatever. There we go, it's got a fix immediately with 5 satellites. Oh well, I just wanted to see. And in case you were wondering, I've turned off the fancy thing on the latest version of Camtasia, which gives a nice circular view of my face. Okay, so that is it for this video. We've done what we came to do. We've got the GPS module working, and I am just going to go right through all the sort of peripheral little modules I've got and get them working and figure out what I need to wire into the main processor. So at that point we can start designing a PCB for our nuclear module to go on, but I don't want to get PCBs made and realise I've not connected properly to the modules, obviously. Okay, so that's it for this video. So for now, from Triplicate, it's goodbye. Goodbye.